So last time we were talking about the solutions for our series puzzle, and one of the solutions we came up with is this. And this one has one resistor, 6 LEDs, like all of them do. But this one has 2 strands of LEDs in parallel, right? So you have 3 LEDs in series in parallel with another 3 LEDs in series. So what this looks like, it looks like this. So you've got 3 LEDs, they're all in series, and this branch is in parallel with another branch of exactly the same 3 LEDs. So the first question I have for you today is this. What is the voltage from point A to point B? Now, what do I mean by that? Well, from here to here, what is the difference in voltage, right? In other words, another way of thinking about it, the difference in voltage would be how much voltage goes missing from point A to point B. And if it gets missing, that means that voltage was converted into light by the LEDs. So the real question here is really, these 3 LEDs in series, how much voltage do they need to light up? And we've actually found this number last time. So this is not a very difficult number. So let's talk about why is it 5.52. And you guys already know the basic justification, but I want to show you the actual KVL justification for this. So when we look at KVL for this circuit, we're looking at it loop by loop. So here's my blue loop. You've got a resistor, and you've got 3 LEDs in this loop. And when I talk about the loop, I talk about the path that a current takes. So in this case, the current is going to be I1. So I1, for example, let's say I1 always takes the blue. So when we talk about the KVL for this one, what we're going to have is voltage of the battery, because that's in the loop, right, equals voltage drop of the resistor plus voltage drop of LED 1, voltage drop of LED 2, plus voltage drop of LED 3. When you look at this 3, this is voltage drop from A to B. That's what voltage drop from A to B really is, right? So you know that anywhere over here, you just add them up. So you're going to end up with 5.52 volts. So this brings me to another question. Well, if this voltage drop from A to B is 5.52, what is the voltage drop of our resistor? So you have 6 volts in your battery, and this equals to voltage drop of the resistor plus the voltage drop of these 3 LEDs. This is just voltage drop from point A to point B, so we already calculated this, plus 5.52. Right, so we get something like 0.48 volts. Okay, very straightforward, right? Because together they have to add up to 6. So the next question I'm going to ask you is this. What kind of current do we want to go through our circuit? This is where we stop being scientists, right? And start being engineers, right? Remember, engineers design things. So right now we have designed the circuit. And now we want to choose a few parameters that circuit is going to run on. So let's say I'm going to make a choice. I'm going to make my I1 to be 5 milliamps. And I'm going to make my I2 to also be 5 milliamps. Question, if these two are 5 milliamps each, how big is the current that goes through the resistor? I have I1 going through blue loop and I2 going through green loop. They both are 5 milliamps. What is the current that goes through the resistor if both of these are 5 milliamps? Separately, they are 5 each. But when they go through the resistor, do they go separately or do they go together? They go together, right? This is I total. So I total, if you remember KCL, guys, and you absolutely should remember KCL, is I1 plus I2. This is KCL. So we know that the current that goes through the resistor is I total, and it's 10 milliamps. To be more accurate, that's the current that we want to go through the resistor, because we have just assigned 5 milliamps for each branch. So we want the 5 milliamps to go through each of the branches, and that means we want 10 milliamps go through the resistor. Now here's the question, how can you force this circuit to have I total of 10 milliamps? What is the name of the circuit element that controls the current in the circuit? So in this circuit, we have three elements, right? We have a battery, a resistor, and an LED. Which one of these three controls the current? It's the resistor. Resistor is the one that's going to control the current. So if we choose the right value of the resistor, we actually going to get the 10 milliamps that we want. So the question is, how do we choose the right value of the resistor so that we get exactly what we want? And right now we want 10 milliamps. Well, what we're going to use is we're going to use Ohm's law. So if you guys remember, it was the triangle V over I times R. Since we're looking for R, we're going to kind of block it out and we get V over I. So the formula for the resistance of this resistor is going to be V over I. Now which V? That's the voltage drop of the resistor, and the I is the current that goes through the resistor. In that case, it's I total. So in this particular case, the voltage drop of the resistor was 0.48 divided by 0.01 amps. Remember, we need to convert. 48 ohms, right? That is correct. Fantastic, my good people, 48 ohms. So what does this mean? That means if we have a resistor that's exactly 48 ohms, then this circuit will have exactly 10 milliamps of total current. And because these two branches are identical, each branch will get 5 milliamps each. So now we have completely designed the circuit. So we have designed the circuit diagram. We've decided on this one. We have designed how much current it's going to take. So we have specified everything there is to know about the circuit. And at this point, we can build it. So let's test this out. I actually changed the value of this resistor to 48 ohms. You kind of can't see it because it's blocked out, but it's 48. So when we run the simulation, we get a slightly smaller voltage drop than we have expected. That is normal. Our calculations tend to not survive the contact with reality completely, but it's close enough for us to know that the numbers that we have are actually more or less valid. So let's go ahead and look at the next circuit that we've talked about last time, and it's this one. So we're going to do exactly the same deal for this circuit as we did for the last one. We're going to go ahead and figure out everything there is to know about it. So the circuit looked like this. We had a resistor, and then we had a branch of 2 LEDs instead of 3. We have another branch, and then we have another branch. And you have noticed that in the last circuit, we only considered one branch because they're all the same, right? So this is 6 volts. We don't know what our resistor is going to be, but we do know that the voltage drop of one LED is 1.84. So if we're measuring from point A to point B, what is going to be our voltage drop? So what's happening over here? Once again, when you look at the KVL, and we are looking at just one loop. Let's make this one blue. You've got voltage of the battery equals V of R plus V of LED1 plus V of LED2. And you guys notice, just like last time, right? My branches point A to point B, these 2 points. This is just the value of these 2 LEDs taken together. And we can do this exactly the same calculation with the other loops, right? I can do a green loop, but the calculation is going to be exactly the same because the LEDs are exactly the same. All the circuit elements are exactly the same. As in the case of a resistor, it's the exact same element. So we only really consider just one loop over here. So the question I have for you now is this. What is the voltage drop of the resistor? Guys, this is very straightforward, right? You had 6 volts over here. You have V of R plus 3.68. So we've got the voltage drop of our resistor. So the next step that we are going to do is we're going to figure out what our current is going. And the reason we figure out, the way we figured out our current is very, very simple. We just say what it's going to be. Why can we do that? Because we are the engineers. We are the ones making all the decisions about this circuit. If we say we want this circuit to have a certain current, that's the current it's going to have. So the question that comes up to us is really, how do we make an intelligent choice about it? So how do I choose I1, I2, and I3 in such a way that it actually makes sense and it actually gives us something useful? Well, let me tell you some of the constraints that your current must be less than 20 milliamp. And I will tell you why. Most LEDs will die if you put more than 20 milliamps through them. So your individual currents, the ones that actually go through the LEDs, they had better be less than 20. So choose current less than 20 milliamps. So what is the other constraint? Well, the other constraint is, what if your current is so small your LEDs won't light up? You know, if you have 1 or 2 milliamps, like 2 milliamps, it's probably gonna light up. So anything greater or equal to 2 milliamps should totally work. Now, here's the thing with some numbers, right? The bigger your current is, the bigger your total current is going to be. So that means that your battery is going to drain faster. Okay, so let's do all of these are 15 milliamps. So this one is 15 milliamps, and this one is 15 milliamps. So the next question is, what is the current that's going to pass through the resistor? In other words, what is I total in this case? So we've got 45 milliamps because this is just I1 plus I2 plus I3. So you will notice that even though individual currents were only 15, the big current is 45. The question, remember I told you, you can't have a current bigger than 20 milliamps going through LED. Does that actually apply to our I total? Is that current gonna affect our LEDs? Yes or no? I total only goes through the resistor. It never goes through the LEDs. It splits up before it ever does it. So we can absolutely have an I total that is way bigger than 20 milliamps and nothing bad's gonna happen. So now we're almost done with this calculation because we have just one last thing to determine. We have determined our I total, we have determined the voltage drop of this resistor. So the last thing we need to know is what resistance do we actually need to plug in. So once again, we have a triangle, V over I times R, and we are looking for R this time. So we're going to get V over I, and it's the voltage drop of the resistor over the current that goes through it. So that's going to be 2.32 divided by 0.045. So this is 51.6 ohms or 52 ohms. So now we've got everything in this circuit. So let's go ahead and test this thing out, okay? So what I'm going to do now is I'm going to change the value of my resistor to 56, and we're going to run the simulation. As you can see, nothing burns out. Our voltage drop went down a little, but that's okay. I always say that no calculations meet the reality and survive intact. Because the numbers we get are fairly close to the numbers that we had, we're good to go, really. So the last but not least thing that we want to do is I want you to solve for this circuit. This circuit, you guys going to solve it on your own. What I'm going to do is I'm going to give you the circuit diagram, which you all should know by now. But in case you don't, this is just a resistor and 6 LEDs, and they're all in parallel. So you will have an extremely easy voltage from point A to point B over here. because it's just the voltage of the LED. Very, very, very straightforward. And then the rest of this you will solve on your own.